Imagine standing face to face with a living, breathing Tyrannosaurus Rex. This is not just science fiction, but a possibility explored by cutting-edge genetic research. What would it mean for our understanding of evolution? Cloning extinct species, like the T-Rex, raises ethical questions. Could we bring back an apex predator? Would it disrupt current ecosystems? These are crucial considerations for scientific advancement. To clone a T-Rex, scientists would need DNA from a well-preserved specimen. The challenge lies in the degradation of genetic material over millions of years. How could researchers overcome this obstacle? If successful, cloning a T-Rex could revolutionize paleontology. It would offer unprecedented insights into dinosaur behavior, physiology, and the conditions of their world, long lost to time. Scientists have already made significant progress in cloning animals like the woolly mammoth. However, the T-Rex presents unique challenges due to its size, complexity, and the vast amount of time since it roamed Earth. Modern cloning techniques involve inserting preserved DNA into a host cell. For a T-Rex, this process would require finding a suitable surrogate species, likely a bird, given birds' evolutionary link to dinosaurs. The ethical implications of cloning a T-Rex cannot be ignored. Questions arise about animal welfare, potential ecological impact, and the moral rightness of bringing back extinct species. These issues must be thoroughly debated. While the technology to clone a T-Rex remains out of reach, ongoing research in genetics and bioengineering brings us closer every day. The dream of seeing these magnificent creatures again may one day become reality. As we delve deeper into the possibilities of cloning extinct species, the T-Rex stands as a symbol of both scientific achievement and ethical responsibility. The journey to resurrecting dinosaurs is fraught with challenges and opportunities. Cloning a T-Rex would require extracting DNA from fossils, which is extremely challenging due to degradation over millions of years. Scientists would need pristine samples for any hope of success. Even if scientists manage to extract viable DNA, reconstructing the entire genome would be complex. Modern sequencing techniques might help fill in gaps, but the process is far from simple. Once the genome is reconstructed, scientists would face the challenge of finding a suitable host cell. A chicken's egg might serve as a starting point, but significant modifications would be necessary. Transferring T-Rex DNA into a host cell would trigger a series of developmental stages. Each step presents unique challenges, from embryo formation to hatching. If the embryo survives, it would then need to be incubated properly. Maintaining optimal conditions for growth is critical, as any deviation could result in developmental issues. Assuming the T-Rex successfully hatches, the next hurdle involves feeding and nurturing it. Its dietary requirements and living conditions would need to mimic its prehistoric environment. Reintroducing a T-Rex into the modern ecosystem poses ecological risks. It might disrupt current food chains, leading to unforeseen consequences for existing species. Ethical considerations also arise when discussing T-Rex cloning. Questions about animal welfare and the right to exist come into play, complicating the decision further. Despite these challenges, the potential scientific benefits of cloning a T-Rex are immense. Understanding its physiology and behavior could revolutionize our knowledge of prehistoric life. Cloning a T-Rex could also aid in conservation efforts. Techniques learned could be applied to save endangered species, offering new hope in biodiversity preservation. However, the technological hurdles remain significant. Current methods fall short of achieving such complex genetic manipulations, leaving us far from realizing this ambitious goal. As genetic technologies advance, the possibility of cloning a T-Rex may become more plausible, but ethical and practical considerations must guide how far we venture into this uncharted territory. The ethical debate centers around whether bringing back extinct species is morally justifiable. Some argue it's a form of resurrection, while others see it as playing God. From a scientific standpoint, cloning a T-Rex offers unparalleled insights into evolution. Studying its adaptations could lead to breakthroughs in understanding animal survival mechanisms. While the allure of seeing a T-Rex in real life is compelling, the practicality of its existence in today's world raises questions about its place in contemporary ecosystems. In the realm of genetics, the ability to clone extinct species, like the T-Rex, could transform medical science. Discoveries made could lead to new treatments and therapies for various diseases. Yet, the environmental impact cannot be ignored. Introducing a predator like the T-Rex might upset delicate balances in existing ecosystems, potentially leading to unforeseen ecological disasters. Cloning a T-Rex would require international cooperation and regulation to ensure ethical standards are met. Countries would need to collaborate on guidelines and oversight. The cost of cloning a T-Rex would be astronomical. Funding such projects would likely require substantial investment from both public and private sectors, making it a highly debated topic. Public opinion on cloning a T-Rex varies widely. While some enthusiasts are excited by the idea, others express concern over the moral implications and ecological risks involved. The legal framework surrounding cloning extinct species is still evolving. Laws and regulations would need to be established to address ownership rights, safety measures, and ethical considerations. Educational value from cloning a T-Rex would be immense. Schools and museums could offer unprecedented learning opportunities, bringing prehistoric life into vivid reality. Ultimately, the decision to clone a T-Rex involves balancing scientific curiosity with ethical responsibility. The path forward requires careful consideration of all potential outcomes. As we continue exploring the boundaries of genetic science, the dream of bringing back the T-Rex remains a distant one. Yet, each step brings us closer to unraveling the mysteries of life itself. Cloning a T-Rex would require reconstructing its genome from fossilized DNA. However, this DNA is often fragmented and degraded, making full genome recovery extremely challenging for scientists today. Even if we could fully sequence the T-Rex genome, we'd face ethical dilemmas. Bringing back an extinct species could disrupt ecosystems and raise questions about the moral responsibility of humans towards nature. Moreover, cloning a T-Rex would likely involve using a modern bird as a surrogate mother due to their evolutionary relationship. This raises complex biological challenges, as the host body must support the development of a creature vastly different from itself. Despite these hurdles, the possibility of cloning a T-Rex continues to captivate our imagination. It symbolizes humanity's desire to uncover and revive the past, pushing the boundaries of what we believe to be scientifically possible. While the dream of resurrecting the T-Rex remains captivating, it also raises profound ethical questions about our relationship with extinct species and nature itself. Cloning dinosaurs could alter ecosystems unpredictably. It's crucial to consider the long-term environmental impacts before pursuing such ambitious endeavors. Advancements in genetic technology continue to blur the line between what is possible and what is responsible. As we push boundaries, ethical considerations must guide our actions. The potential benefits of dinosaur resurrection include valuable scientific insights. However, the risks and costs must be weighed against these gains. In conclusion, while the idea of bringing back the T-Rex captures imaginations worldwide, it challenges us to balance innovation with respect for natural history and ethics. We invite you to join the conversation. Share your thoughts on social media using #DinosaurResurrection and engage with experts and enthusiasts globally. Support ongoing research by visiting reputable institutions and funding projects dedicated to paleontology and genetics. Your support can drive future discoveries. Stay informed about the latest advancements in cloning technologies. Follow leading scientists and researchers who are shaping the future of genetic studies. Discuss the ethical implications of cloning dinosaurs with friends and family. Encourage critical thinking about the role of science in society. Thank you for joining us on this journey through the possibilities and challenges of dinosaur resurrection. Keep exploring and questioning the world around you. Remember, your curiosity and engagement are vital to advancing science and understanding our shared past. Until next time, keep dreaming and questioning.